Yes. Good evening, everybody. Welcome back into the Dragon's Den. My name's Digital Dragon. I hope you're having a great day and a great week so far. Welcome on in, Outcasted Wanderer, Free Heathen. We got Nick, Chewy. How's everybody doing? Testing, testing. 1 1 2 2 3 3 3. I am not a robot. How's it going, Free Heathen? Hope you're doing well. I was looking for a stream earlier from you, but I'll be honest. I was in and out of meetings so much today, and that's pretty much my life right now, which is sucking. So, um, not into the meetings right now, but it is what pays the bills. So we got to muddle and struggle through. Hey, Killer Prince, how's it going? How you doing, my friend? Um, so as you can see, there's still something here. If you've been on the last couple of streams, you know what this is. Um, you're off on Tuesdays and Wednesdays. There you go. There you go. So this is a Trident 350. It's still sitting on the bench, so we're going to have to do some reorganizing. But I wanted to show you where we were at with the Trident 350. And of course, the camera goes all kinds of haywire because why not? There we go. There's a Trident 350. If you notice, there's a little something missing here, right? So I gotta be careful when I drop this off. So I got everything running. I have it homing reliably now. I worked on it all weekend long, to the point where I was up until 3 a.m. Sunday morning and then 2 a.m. Monday morning, which made yeah, which made Monday a very rough day at work. But this is a Trident 350 that's been switched to an all metal, all wheel drive gantry with 9mm belts using the Cyborg kit. It's got a takeoff tool head with a tube in it with a 1.0 Undertaker nozzle, 100-watt heater, PT1000 thermistor. And what should be mounted right here is an FXD extruder. Except here's the issue. I thought I was going to be sneaky and use a Bondtech motor because the FXD looks very much like a Bondtech LGX. Well, there's my issue. The reveal from the front of this plate to the front of the black circular piece to the front of the pinion drive is 5.2 millimeters. The CNC machine backplate to the gear drive is 5 millimeters on the FXD. So basically, every time I put this in, I screwed it all the way down. This gear is effectively pushing where, let me grab the extruder. The drive gear is basically pushing right where these two gears join and is stalling the motor, or worse yet, driving the motor and causing inconsistent filament. So I've got two different motors on order. One is the advanced 3D printing specific motor, and the other one is a LDO pancake motor. So I'm going to see if whichever one shows up first works. If not, I'll wait until the A3DP shows up. The other potential option would be to take that off completely and put a, I don't know, an LGX Lite or an LGX Lite Pro on it, or a Sherpa Mini. If I do the LGX, I have to get a different plate, top plate for it. If I go with the Sherpa Mini, it's going to have a round pancake motor, which means I need to switch over to an EBB 36. So pros and cons. I don't know what I want to do. If I go with the Lite Pro, once again, I have to get the A mount and do some other things. So which means this one's going to be shelved for a little bit. I will tell you, I did get filament going through here. seeing a 1.0 thick filament being shoved out of the nozzle is a sight to behold. So I cannot wait to get this up and running, but it's moving, it's homing. We've got it set for sensorless homing on the X. And then it backs off 50 millimeters, goes back and does Y. And the reason being is if I don't back off the 50 millimeters, the rear of the tool head board hits this motor. So I have to back it off, do the Y, and then it'll come over and the beacon's working, everything's set and everything's working. I just need to figure out the extruder. That said, I'm going to take this and set it down on the ground as far out of the way as I can. We'll get our mat out of the way here. Let's toss that out of the way for now. We'll get our build surface back up here. Who would have ever thought that quartz could be so heavy? Or actually not quartz, but is this quartz? I can't remember. Quartz, marble, whatever it is. Pretty flippin' heavy. Oh, and finally started putting this together. I apparently felt the need to add gloop in wrong places, so I'm going to have to try and sand that down. But still got a bunch of greeblies and stuff in here that I need to put on there, but we're starting to get the bolter put together. And I'm thinking I'm just going to reprint this in TPU rather than spray it black and loop that on. But we'll see. We've got our storm bolter going. Or excuse me, our bolter going. The storm bolter is over here still. I figured as soon as I said baby belt, Maker was going to be here. And if Maker was going to be here, then I needed to show off that. Hey, Shrimp Father, welcome in. Welcome in. Timor, welcome in. Hey, Eagle the Dragon. Easter Sunday is next week, Eagle. Or I guess this coming Sunday, yeah. Killer, you think the Light Pro? You should get rid of it. Send it to you for use. Yeah. I see how that is, Killer. I don't know. We'll see. We'll see. We'll see what I bring to Rocky Mountain with me. How's it going, Outcast Wonder? Back to work, Slacker. The animal is here. Yeah. So I wanted to show off these parts. These parts were printed on the Creality, and these are printed in Greekgate, Your Royal Highness. And it's PET G, so it does have that little bit of, you know, faint stringing, kind of cotton candy thing. It is dried filament, but you still get like the faint hairs on there. But this is the Devil 3D or Devil Designs. These are the Devil Wears Prada boots for the Creality. So I printed these out, but interestingly enough, this is the same color I'm using for the baby belt as the primary color. So, yeah, you've been using Greengate? Yeah. So Greengate is one of the filaments that Ecovate 3D carries and sells, and they actually can sell the pellets as well if I wanted to do a pellet extruder or extrude my own filament at some point. So I can buy it by like the bag. But this is a baby belt kit, a baby belt pro kit, I'm sorry, by Fabreeko. This is a sponsored build by Fabreeko. They did send me this kit free of charge so that I could build it on stream and get some more excitement out there. These kits, I do believe, are available for sale on the site today. So if you want to go out there, you can and get one of these yourself. It comes pretty much with everything you're going to need except for the printed part and a belt. So let me before we start getting in here, let me flip over real fast. Yeah, it looks really good. I was surprised. So this is, once again, a bone stock Creality K1C going on behind me here. And these are this part over here on the left is the skid plate or the ramp plate where the parts will exit from the printer. And the part here that's going on in the back, these are supports coming up, is the front of the printer where the screen's going to mount. So we won't be able to make a huge amount of progress tonight, but we're going to unbox, check everything out, make sure we have everything, and then we'll go ahead and get started on the build. Where does one get a belt for this? Funny you ask. Funny you ask. So this is the Mink Baby Belt Pro GitHub repository. And it talks about, you know, getting your kit and getting information from here. You've got a build and info. So this is a single page wiki. And it talks about the various things that you're going to need to do for here. So it talks about, careful, don't slide the carriages off your rails. The print info. So unless noted, no supports are needed. The parts are sized for PLA and are orientated in the default position. 0.2 layer height, 3 to 4 parameters, 20% or more infill. And if you're doing PETG or ABS parts, you might want to scale 102 to 105%. And if they're very sensitive to that sizing, they do mention that. Here's what I'm going to tell you. I only sized up the parts that they said were sensitive. Everything else, I'm printing PETG at the PLA size rate. I did not update everything. We'll see if that bites me in the butt later. So this goes through and tells you, and this is what I like, what you're printing and what it's going to look like, and then how many are needed, right? Make sure no excessive elephant's foot on these parts. Has an optional mod parts, meaning there are different mods that you can print here rather than just printing the plain one. Same thing for the screen mount. This one does say 6 parameters higher infill. This is your dual motors. This will run your X and your Y motor. So you need to be aware of that. It's going to be a stronger part, so make it a little bit beefier, right? Hey, Petty Ruxpin, how you doing? Hey, Daisy, welcome in. Welcome, welcome. Your mounts. And once again, we're just going to go through here. Here's one of the parts. It's a screw-on part where it says if too tight or printing in PETG, you might have to scale it up. Here's another part where it needs to be 5 or 6 perimeters. So that's good to know. That's a high stress part, a tension arm. So you just go through here and you make notes of what you need to do. And where it says you might need to make them a little bit bigger, make them a little bit bigger. On your gears, you are going to use printed press-on gears for your belt drive. If it goes on very sloppy, you might have to make it a little bit smaller so it's a tighter fit on your gear. It needs to be an interference fit, and it needs to be snug for that particular gear that's going on the D shaft of the motor. Here's a part that has to be PETG or ABS if you're going to run the heated build plate. If you're not going to run it heated, don't worry about it. PLA or PETG is fine. If you're going to run a heated build plate, then you want to run PETG at a minimum or ABS, ASA, yes. Either one of those. Here's another part. These are the rollers that are at the front and back. These need to be high strength parts as well because this is what you're tensioning against. So make sure 6 or more perimeters. I think I did like 8. Yeah, you can do carbon fiber PET. Um, Other parts needed to be made. Print belt. So funny you should mention it. There's another link here to go and talk about making a Baby Belt Pro iron-on fabric belt. I haven't done this yet. I just figured out my colors and started printing stuff yesterday, and I haven't been down to either Walmart or Michael's to go and see what materials are available. So we're going to have to go and figure out what material we want to use. But you're going to need cotton fabric, iron-on backing, and Kapton tape, which I have plenty of. And we'll go through this process and kind of review it. I'm going to have to figure out how to iron it. I may have to put something on top of here or of this work surface so I can iron it without damaging it. But yeah, if you have a printer that can print peak, you're not building a baby belt probably. But anyhow, this is pretty cool because you can use just about any fabric pattern you want. So go down and go to the store and find some different patterns and try. Now, the thing that you want to be cognizant of, you need it to be 5 inches by 15 inches long, which means if you're going down and looking at like quilting squares, you need to understand what the size of the square is because you need at least 15 inches. So you're probably going to have to go and just buy a yard of fabric and maybe buy 2 or 3 different patterns if you like. Okay. So with all of that said, we're not going to be making a belt yet. We will need a belt before we get too far along in here. We may jump around some tonight just to keep making progress. And I will go get belt material hopefully tomorrow. Because I got to go out. I'm going to go into the office tomorrow. Long day, which ends with a what type of fabric? Cotton, nylon, hemp. It specifically says cotton. Okay? And on the cotton, when you cut your belt, you want to be, you want to be cognizant of the direction that you cut it. Okay? The tools you're going to need: an iron, ironing board or other surface, measuring device, and fabric cutter or something else that can make clean and accurate cuts. You're going to take your cotton out and iron it if it needs to be to get any creases removed. This is a critical part. This should have been bolded. Okay? Give it a pull in both directions. One way will be stretchy and one way will not be. We want the stretchy way to be the length and the non-stretchy to be the width. So the non-stretchy needs to be the 5 inches, the side to side, and the stretchy bit needs to be the length that you're making around the belt, and that's going to help when you tension your belt. Okay? Yeah, it's going to be cotton. And then basically what you're going to do, well, all right, we'll walk through this. So the iron-on shrinks, so that's why the iron-on backing is cut 5 inches wide by 15¼ inches. Gives you that extra 1/4 inch, 5 millimeters for it to shrink as you heat it up and it bonds. Okay? If you've got the backing, remove it. Not all of it has it, but if you do, go ahead and remove it. And you're going to use the Kapton tape on the non-glue side. So you're going to take your backing with the glue side on the outside. You'll fold it in on itself, and the Kapton tape goes on the back side that doesn't have the glue. Okay, so basically you're making a round belt out of your backing material. It doesn't need to be duck canvas. Then you'll position the fabric with the visible side that you want down. Normally on this type of fabric, one side's very bright, vibrant and the other side's kind of muted. So you'll put the vibrant side down. And then basically you're going to start with that middle seam of your backing material at the middle of the belt. What you don't want your two seams to be overlapped. That would be a bad joint. So you put the seam of your backing material about in the middle of the belt, and then you're going to tack it from both ends or both sides, and that's just going to help tack it into place slightly. And you want to be very careful and make sure that it's lined up and not at a bit of an angle. That way you can get the whole thing on there. And then basically you just start working it back and forth, side to side. Don't go all the way to the end. You want to be able to clean up any frays that have developed in the fabric, and then you'll go and seal the end in. Now, he says that this is good enough, that if you have a little bit of a miss there, that is a good enough belt. So your mileage may vary on how you want to do yours, but we'll need to do this before we're able to actually put the belt and bed together on the printer. So once again, we'll be working on that most likely Thursday. I'll have to stop and pick up some material tomorrow while I'm out and about. But real fast, let's go back to the bench side here, and let's kind of open our box of goodies here. There's two different hot ends that you can do. The default hot end is this TZ 2.0. This is very similar. This is the same thing that was used in the Rooks, in the Rook 2020 Mark II. This is basically a Bamboo Lab knockoff hot end. Knockoff's fine. You don't need a stainless steel or a hardened steel nozzle for a baby belt because you're probably not going to be running ABS. Yeah, some gapping is not an issue. And you're in ads. Uh-oh. So ad break's almost over. We'll give it just a couple of seconds so that Heathen's back. I don't know about seal leather, but probably not. I mean, if you really want to, I know there was a company that was doing belts for their version of a belt printer. I'm trying to remember the name, but they sell belt nozzle or nozzles for belt printers as well as belts, and they can do custom sized belts. I'm sure they could probably make one that'll work for this size. That'll be more along the lines of like what a CR30 belt looks like. So we're going to be using one of these hot ends. This is a TZ, so I think this is basically a Triangle Labs knockoff of the Bamboo Lab P1 X1 hot end. The same type of thing that you use with the Rook 2020 Mark II. The titanium alloy heat break, hardened steel nozzle for the Bamboo X1 P1. You really don't need the hardened steel nozzle, but And the nice thing is I have a couple of X1s and I have spare nozzles, so if something happens and I damage this or whatever, I can just swap one out. We've got a hot end. This is the heater and thermistor. So this is a little ceramic heater and a glass bead thermistor. There are rumors that a different type of belt are coming. Okay. To keep on the theme of inexpensive, because once again, I believe this is I think it's a $300 kit, right? But to keep with the theme of inexpensive way to get into belt printing, we're going to be using a knockoff Bondtech extruder. So standard knockoff there. Will work just fine. We're using it in a Bowden type setup. We're going to be using the ubiquitous SKR Mini E3 V3. A lot of our smaller printers use these. We've got a TFT 35 E3 edition. So this will be more of the squarish looking screen. I say squarish body, I mean rectangular screen, but the squarish body. This would be a drop-in replacement for an Ender 3 display, right? So we'll be using one of these. Lucky. And this comes Marlin with an option for clipper. And my plan is this is going to stay a Marlin based printer. This is our LDO bed. Interesting that this is a standard LDO style basic bed for a Voron V0 with a honey badger heater that you put on. You can use one of these. This is, I'll say, an older basic style, or you can use the polyamide heaters that LDO now has out for these. Bits, bobs, and gubbins. We'll dig into that in a second. We've got the power brick. This is a pretty small printer, so it uses a DC inlet for power. So this is your actual power supply. Make sure you get a 24 volt so it works with all the electronics. This is also, it can be a backpack printer. Very few backpack printers these days. Well, Mitch had one. He normally is the backpack printer guy, but there's a potential. I don't know about doing a box turtle on this for color changing. I'm not sure how that would work very well on a belt printer. Oh, like a travel printer, yes. Here's our motors. These will be used for the X and Y. These, I believe, are 11HS18s. I believe these are NEMA 14 motors, or maybe 8s. Might be 8s. But these are for the X and the Y. Put her down. The second one, we got 2 of the smaller motors. And we'll have 2 of the larger, more regular style motors that we're used to. And these are the stepper online. Yeah. NEMA 17 motors. These will be used for the Z drive and the extruder. Yeah, so I'm planning on bringing small printers to Rocky Mountain this year. Easier to go because we're driving out. I don't want to be driving and staying in hotels for several days with big printers sitting in the back seat of the truck, you know, waiting for somebody to break in. But yeah, there's the, pretty standard stepper online motor. Um, and then this is a baby belt, so we get baby rails. We get tiny little baby rails. I believe these are MGN 9s, I believe. So we'll use 2 for the X and 1 for the Y. But I'll set those to the side. See what we have here in the Gubbins arena. GT2 pulleys. Look at these baby little things. These are like small. These are GT2 6.5 16 tooth pulleys. 6mm Gates belt, 1.5 meters. Short motor wires. Oh, these will be for those two. There's our power inlet. Some M8 nuts. Some M8 bolts. PTFE tube. An idler pulley. So kind of like the big pulleys, but this is just the idler. Come on. So a little guy. Some non-tooth idlers. M3x10. M2x6. 2.5x12. M3x20. Some M3 nuts. Oh dear God. Tiny M2 nuts. That's going to be dangerous. I can see how many I'm going to lose of those. 2.5x8 hex. Power inlet. 2x6, 2x8. Part cooling fan. And some standard skateboard bearings. That's pretty much it. That's all the parts for a baby belt. Not a whole lot. So rather than using heat press inserts, we're going to be using, come over here, and station properties. Yeah. Over there. Oh, all right, I know what I need to do. There we go. That makes us. Aye, aye, aye. There we go. Okay, so we're going to start with the base assembly, and I've got the bases printed. So I've got that part done. This is the side that they want us to work with first. So we're going to be putting some nuts in here. It says first make sure that the holes at the bottom of the frame sides are clear as well as the captive nut holes. So we want to make sure that our holes that printed down here are pretty clear, that we don't have a bunch of gunk in them, and that these holes that printed here, since it printed in this orientation, that we don't have a lot of sagging or anything that would prevent our M3 captive nuts from going in. So we are getting that VFA ripple. This type of VFA right here, this is normally caused by the belts. Doesn't really mean anything is wrong with the print. You're just going to get that ripple in it. So everything looks good there. And everything looks good on this part. So you've got, on this side, you've got the power switch, the power inlet, the SD card, the SD card and the power or the USB connector for the SKR Mini. And then this right here would be a punch out if you wanted to add a Raspberry Pi. So we do have the studs for a standard Raspberry Pi or a Raspberry Pi Mini in here. If you wanted to run a Raspberry Pi and be able to do, you can still run Marlin, but you can put a Raspberry Pi in here and run Octopi on it and stay with Marlin, or you can make this clipper if you want. There are firmwares for both listed. Okay. So we made sure the holes are clear. We're going to start with our power jack components, which means we need to start with this side, which will be the left side, because this will be the side that our front plate with the screen goes on. This will be the left side. And we're going to be needing our power switch and our outlet. And they are nice enough in the kit. You'll notice in this screenshot that they had to solder some things up. But in the kit, they've got proper ferrules on the one side that's going to go to the motherboard. And on anything going into the switch, they've got the spade connector already terminated on there. And you'll notice that the power inlet itself is already pre-soldered. This is something that's coming nice from Fabreeko as part of the kit. You even have a rubber piece that you can use to put over your inlet. I mean, this is part of the part that you would buy on Amazon, but you don't need that, but you can put it on there if you want to, just to protect that inlet when you're traveling with it or taking it places. We're going to start with the power switch and make sure that it's orientated correctly. On the power switch, you've got your two locking ears here. And on one side, you've got this keyed feature. And you'll notice on your print that you have the little keyed piece right here. So that tells you how to orient your switch when you're going to install it. And it's just going to press fit. So you'll get your little nub lined up with that little divot in the printed part there. And that'll act as a guide, and you just push it in. Like that. Pushes in, the little wing towels will pop out, and now that's nice and secure and not going to go anywhere. Next up, we're going to install the power jack 2. The jack secures in with a nut on the back. On the inside of the printer, no need to put the rubber part on if you have it, only if you want to, right? So if you wanted to put the rubber part on so that you could cover it up, you would just take the rubber part, run it through the wires, bring it up on your on the outside of the printer there like that, and kind of shows like this ring is on the outside. It shouldn't be. It should be on the inside because this is a locking washer. That should definitely be on the inside. So feed your wires from the outside in. Really doesn't matter the orientation. How do we want to? Doesn't matter the orientation, but I'm going to kind of put it so that my wires in the curve are curving towards my switch, because this is going to go on the switch. So I'll curve it so that the wires are going in its natural order. I'm going to flip this down just so it's facing down. I'm going to hold it there with my finger. We need to put the locking washer on. So make sure it goes around the wires. Put your lock washer on. Then you're going to take your little nut. Once again, run it through your wire, or run your wires through it. Bring it down and just tighten that down. Now, you can just hand tight. It doesn't need to be, like if this was metal, you would maybe crank it a little bit more, but it's hand tight. There's no need to try and bust the plastic. There's what it's going to look like from the outside. Okay. Now you'll see here we make the power connections. The positive is on the inside of the jack. Yep, the positive pole, the red wire, is connected to the inside of the power jack here. The outside, which is connected to the outer edge, is your ground, and that's going to ground. You're going to come out of here and go into your switch. And I don't think it matters whether it goes to the inside or the outside, but I'm doing it to the top of the switch there. And then my other power cable, my red cable, is going to go at the bottom. And I like that they've got the spade connectors and they've got the insulated ones on there. That's really good. I like that. Okay, so we've got our wires in there now, and we're wired up. So, okay, fine. They show the inlet going into the middle. So let me, guess I should have looked. I don't know that it really matters. It probably does. But now we're right. We've got this going around to the middle like it shows in the picture. And then the top one would be our other one that goes with our black to go to the machine. Hey, Creatix Brit, how are you doing? I hope you're doing well today. Yeah, all the connections being finished and all the connections being finished properly is awesome. Okay, now we're going to grab our SKR Mini E3V3 out of here. I didn't open this, so I didn't grab the ducky out of here. The ducky was in the screen. There was no ducky. I got gypped. There was no ducky in the SKR Mini E3V3. I need to complain to Big Tree Tech about that. They are messing up my ducky collection. I'm doing great. The Trident build is sitting over here on the ground. We had an issue with the extruder and the fact that I bought a Bondtech motor thinking, okay, that's going to be great. That's the same Bondtech motor that runs in the LGX. The FXD extruder that I'm using is basically a all metal souped up version of an LGX. The spur gear and shaft on this motor that I have on here is 0.2 millimeters, so 0.2 of a millimeter too long, and it's binding the gears on the FXD extruder. So I've now purchased the Advanced 3D Printing, A3DP, who makes the FXD. I purchased their specific motor for it. Okay, we're going to need to install some jumpers on here. So you've got your power inlet and your hot end and bed, or bed and hot end, one of the two. Doesn't matter. And then here are your end stops. And right here are 3 jumper spots that you need to add jumpers to. This is to allow sensorless homing for all 3 axes. So we're going to take one of our jumpers and just put it on those 2 pins. And it doesn't show it here, but here's where it shows all 3. And so there's our 3 jumpers added to those pins. And that's to enable sensorless homing. Yeah. Return it. It's not in proper working condition. I have like 6 of them here. It's no big deal. I'm just complaining. I remember somebody on my Anycubic video, it was like, complain, complain, complain. This is on YouTube, by the way. The only thing I complained about was the fact that the switch on one printer was on the right side and down was off, and the switch on the Ace Pro unit was on the left side and was in the opposite direction for on and off. If the switch was at least in the same direction, I wouldn't have complained. But to me, that's a safety thing. Okay, now we're going to install the board into side A, the side that we have added the electronic, the electrical inlets and the switch to. We're going to take this, we'll set this aside and take this, and we can, I don't know, throw it in the garbage. We don't need it anymore. We've got a couple of jumpers. We'll add that to the pile of jumpers that we have over on the bench so that we have them. Sounds like they just wanted something to complain about. Exactly. Yeah. Okay, so we're going to look at the way the board goes on here, and we're going to use M3x10 screws, 3 of them, to screw it down. And it's going to be on these 3 standoffs right here. So I have 1, 2, and 3. And I almost feel like this would have been easier to mount the board first, because now we're going to have to do this one and kind of work around the switch here. Order of operation thing, that's it. And the board goes with the power outlets hanging off the edge here. Okay, so that's the only way. We're going to line it up using this screw, and the one in the center. And once again, we're going to use our M3x10 screws. They're using flatheads. I don't have any, well, that looks like flatheads there. I just have socket heads. I'll say 6 1/2 dozen the other. And okay, we'll work around it. I was just looking, my ball end driver will be good to use on some of these, but now we're screwing into plastic. So do not ugga-dugga these. You'll strip the plastic. Hey, Rob, how's it going? Just joined. Anything you should take care or take note of? The only issue I've had so far, Rob, is we probably should have mounted, and I'm going to have to go get my ball end drivers. Give me 1 second. We probably should have started off mounting the board and then adding the electrical, because now it's going to be hard to get to at least this one, because there's no easy way to go straight up and down for it. But yeah. So bear with me. I need to go grab my ball end drivers, which are downstairs. I will mute you guys real fast and I will be right back. All right, that was perfect timing. I got down there right as Mrs. Dragon had gotten back with Duncan, so I've got fresh coffee. Okay. So we need our 3mm, or excuse me, our 2.5mm ball driver to get these going. And once again, you're going until they're just snug. No need to try and ugga-dugga these down. You just don't want the thing to be loose and flopping around. And no, so far I'm doing good. We talked a little bit about the Trident 350 build that's kind of stalled right now. I've got everything working on it, and then I realized that the extruder on it is binding because the shaft and pinion gear on the motor that I bought is 0.2 of a millimeter long, longer than it should be. And I'm glad you're here because I missed the one comment that you made on here, probably because I didn't come down here and read this part. A ball driver. They ball in Allen key, ball in hex driver. Really? That needs a tune and a drop in the mail. I'm home early from work today and not going to have to work till 8. That's nice. Needs a tune and a drop in the mail. Not sure what you mean by that, Rob. So the other thing that I forgot, you need to make sure that your ports are accessible, which means do the old school thing like a motherboard. Don't just jam it in like that, like I was doing. It needs to get kind of twisted, kind of lift it up, line it up, and drop it down in there. And that way your SD port is properly there. You've got plenty of room there for your USB port because of the, the big connectors that you're going to need for that. But that SD card slot, you need to make sure is properly aligned. So now we'll go ahead and get this started again and get it screwed back down. Don't screw it all the way in. Get all 3 of your screws started first. That way, if it needs to shimmy shake some, you have the ability. Again, the threads on your screws need to be going straight up and down, not at an angle. I just got back from an ad. Okay. So I was asking, you made a comment about something needs to be tuned and dropped in the mail. I don't know what you meant by that. On you. Downside of trying to use ball end hex drivers, trying to get a screw started in plastic. Oh, you talked about it 2 years ago? Well, we could have been lucky. Might have been at Rocky Mountain this year. Actually, I have a box that's that I need to get going to Mr. Millwright. Provided the mail system with the latest tariffs and stuff, they don't want like $80 to ship a box. Okay. So the board is now secured. Everything's nice and snug. Let's see. Now we're going to take and put the two sides together. We're going to use M3 by 20 bolts and M3 nuts to put this together. So the bolts are going to be coming in from this side. This is going to be the receiving end, so we need to put 3 M3 nuts in here. Oh yeah, I'm not sure if, because I don't know, I haven't been following the news to see if there's like retaliatory tariffs going on and all that good stuff or not. So these are falling in nicely and they're lining up, which is good. I'm going to make sure that those stay lined up. Now you've got these little keyed features here on both sides that'll help line this up. That will help line this up like so. Probably should have got a couple of these ready ahead of time. Yep, only need to do the middle at this moment. We're going to take our middle one, drop it down in there. We'll grab our driver, fish around for it. There we go. It's cinching up. Thought it was. There we go. Ah, I get it. I think it's got a little bit and it's twirling around in there. But we're good. We're decently snug. The other two, as you can see, if I put a driver through here, will come through these two slots here. And that's what's going to lock in the front and back plate. You know, the front and back plates that are still printing. So we may not be able to do those. And I'll probably set this over and drop these two out. And we'll have to put those back in later on when we go to do the front and back. which I believe are probably going to be the next 2 steps. We tighten it up to secure the 2 sides together, only doing the middle one. Yep, and now we would be taking the front plate and installing the screen in the front plate. The the front plate's still printing. We're about halfway done, so we got about 3 hours left. So we may need to skip forward a little bit in our procedures. You'd install the screen, install that, da, 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 da. Should be able to do that. So Rob, would it be best before we start messing around to go ahead and install these wires now as we're going along? I think so. I think it's the easiest way to do it is do it while you have the easy access to things. Especially when you can see which side is which or power. And jump around here to the wiring. Ground is closest to the edge. 24 volt is closer to our whatchamacallit, the fuse. Yeah, you do all the wiring at the end, and I get that. It makes sense. It makes sense to do all of that at the end. However, I would at least say get your power in. I would probably say first, that way you're not having to deal with these wires and then all of a sudden your wire's down here under the board or something and it makes it harder to get to. I would probably say do these initially since nothing's in the way, and I would probably say do that before you even install the side, because that way it makes it easier for you or for any first timer to ensure that they've got the wire in there correctly. Since this is kind of imperative to not burning it down. Okay, so those are wired there. That's good. Note that there is some like little troughs built in here to help be able to zip tie things to, I'm assuming. And once again, we've got the nice spot here. You can either put a full-size Raspberry Pi or a Raspberry Pi 0 or 02W in here, so that you can run Octoprint or what have you right from this board. Yeah, so that was that. I'm going to come back up here, base assembly. We got that installed. That's running it together. We can't do the screen and we can't do the ramp or the belts. Let's go ahead and install the motors. Now I do want to say both of the motors are supposed to be big boys, right? Or are they supposed to be smaller? Because I'm going to look at this and this big boy. I mean, it goes, but fairly tight. Yeah, it can be any size 17. Okay. I'm sure for the rear, because this almost looks like a NEMA 17 pancake motor versus the big chonky boy. In which case, quite honestly, I do have one of those. 1.8 degree NEMA 17 high temp with a standard size shaft. So we might go this route, at least for this one, because it will give us more room as we're trying to navigate around here. Back here, it's not as big, or it's not as bad, because this will be driving the this one's driving the bed. So yeah, but some are from the beta. Okay, cool. Hey, Reprinted, welcome on in. How's it going, Pete? Yeah, so I'm going to switch over and use this LDO pancake motor. I think that'll work just fine. It'll work just fine, except we're going to need to press on a gear, right? No, not the gear for this. Not the gear for this one. This one involves this. Nice little case if you need it for anything. An extra amount if you need it for something. Or you can throw it away. I think I've got 8 of those. And we get to build the BMG kit. So, start by pulling it apart. We need, motor will go inside the frame with the extruder on the outside. Follow directions for your specific extruder. You would advise to install the motor with the wires not facing up, but instead back at the screen. So you want your motor wires facing the front screen here, and that's just to allow for easier wire routing. If it's up, then you're having to basically bring it across. If it's facing the front, you can bring it right down and plug it in. You'll need to change current on the motors if you use not the motors in the Fabreeko kit. Yeah. All right, we'll run the Fabreeko one. We'll build the kit. We'll build the kit the way the kit came. That's what we're going to do. Okay. So this has that gear in it. The extruder assembly notice. We need to make sure that we build our extruder assembly as needed. Sit down to do this part. I know. Okay. So gear mounting positive. Tooth end is close to the motor. Okay, the distance from the motor is about 3.5 millimeters. Okay. So our tooth end, that's the little sucker we got to find. Awesome. So make sure you don't lose the tiny set screw, or that you have a bunch of tiny set screws available. Hey Liz, welcome on in. How's it going? Get a little bit of Loctite on that. You do not want your extruder motor coming loose. We'll go ahead and get this started. And this is going to go on our stepper motor with the whatchamacallit, the set screw to the D side of the shaft, and we're going to want about 3 millimeters. Go this way. Tooth end is close to the motor. Yeah, I think it goes the other way. Actually goes the other way, because if it doesn't, then it won't be on the flat side of the shaft. And we want a 3 millimeter gap. So how do we figure out a 3 millimeter gap? Well, it says 3.5. This is a 3 millimeter ball end driver, which means this should be about 3 millimeters. So if I set this in here, flat end up against this, I should be able to set this to the right location, just like that. Or you can grab a ruler and measure. You can use just about anything. Yeah, losing grub screws would be bad, especially if you get hungry. I hear they can be snacks. I think they're Nero snacks. Okay, so we did that. One end is close and the angle between them is 30 degrees. That sounds weird. That just sounds weird. Okay, this end is basically going to line up here, and you want to make sure that your tooth gears are going to line up, which it does. So that's good. Now I'm going to take that off because this has to be installed through the back. So from the inside here, slide that through. Once again, with our motor jack facing the front of the printer. Okay. We'll need this part. That part. Okay, yeah, that gets a screw-in fitting on this side, ECAS fitting on that side. Those two are lining up, yada yada, yay yay. Oh. Yeah, they look like they're lined up right. Okay. So we'll put our tension spring on here so it stops flopping open on us. I'm not going to make it tight. I'm just going to get it on there so it doesn't keep flopping open. Okay. Actually, we'll go ahead and put this in because if we don't do it right now, it might be painful to do later. Just from an access because of where we're going to be putting this. So go ahead and get one screw started through here. We're going to line it up with the top here. We'll get this kind of in position, holding it with one hand. That lined up. Lined up on the motor. Yes. Okay. Do the other one. And I'm pretty sure we wanted this. Yes. That is the correct orientation based on our photo up here, which you can see the bottom of. There's our correct orientation. Now, the one thing I did not do, and I might have to do this off stream, is the Ray Ray. Welcome on in. How's it going? Hope you're doing good. We are working on a baby belt printer. Thank you for the follow and welcome on in. Will grub screws with lithium grease screw up your HDL levels? I don't think so, but you never know. Do not eat grub screws and lithium grease. Lithium grease helps smooth them through. It is a very small belt printer. Is there a, you see if towards the end here it shows, yeah, that's kind of close to, well, that's with the bed out. Here's with the bed fully in place. Kind of what we're working to is this little small belt printer. Yeah. And so I'm kind of working my way through the things that I can do because I'm still in the process of printing parts. So there we go. We got this installed. Now, the piece that I was just talking about is, oh, I didn't do something. What didn't I do? As Liz might know, a travel printer, some would say yes. There's bearings here. There's bearings there that don't have any grease on them, I'm sure. So let me see if I can pop this end out without breaking this wonderful injection molded plastic part that I can't get from Amazon in a day. Yeah, lube it. Seriously? Do not make me have to take you back off. It's gonna make me take it back off. But that's what I get. My own fault. I just didn't even think about it until I was almost done putting it in. I was like, ooh, that's got a set of needle bearings in it that hasn't been lubricated. Come on. So I need to punch this back out so that I can get this off or figure out how to lever it off of one side. There we go. And get the one side off, I can get it out. Should be able to get it out. Give me the gear. Don't break, but give me the gear. You me. Oh, that's one way of getting it off. Now there's my two needle bearings. Rise bone. Here's the shaft. Okay. Now, let me grab a piece of paper towel. We'll grab our lubricant. Our lubricant of choice is EP2. And I have a glove up for, oh, yes, I got a glove. Cool. Glove up, just so we don't get grease everywhere. I was missing a finger, but that's okay. I can work around it. And what we're going to do is we're going to take our idler. The idler is the one that doesn't have a grub screw in it, by the way. Put it on a finger that's got a glove on it. You're going to take your 2 needle bearings. You're going to slide them in as a stack. And then you're going to take some grease. This is EP2. Hey, tugboat. And you're going to squirt a bunch of grease in there. Don't worry, just fill it all the way up. Because now you're going to take this shaft and you're going to stick it down in there. Now with your finger at the bottom, that grease isn't going to have anywhere to go, and it's going to start getting squished into those bearings. And you'll see how that needle bearing started popping out there. There we go. See how that needle bearing's popping out? That's because the grease is pushing it out. So you push that down with your other finger, continue to push that all the way through. You see all that grease coming out now? That's perfectly fine. That's the excess grease. Now we can wipe that off. Now, if you get a little bit of grease on these gears, you're fine. You do not want grease in the teeth. So look for grease on the teeth and wipe off any that may have gotten on the teeth in the filament groove. Grease on the other side, no problem. Now we're going to need to take and drop this back in and making sure that we line up the drive gears together. So in this case, the drive gear, the thicker piece, goes in the back. We're going to line that peg up. Kind of click it in there. Click it in there. Darn you. Why are you not wanting to go in? Because I'm streaming. Seriously. Ah, there we go. That popped in. Make sure your pin's pushed all the way through so it's flush on both sides and can open and close easily. Drive your gears to make sure everything's lined up. Put your tensioner back in there to keep it somewhat together. We'll worry about tensioning this later on. How's it going, tugboat? Now, once again, we're going to line up the connector port on our motor facing towards the front of the printer. Set that down on there, making sure that it's engaged the drive gear. Then we're just going to screw these two halves together. One started, get the other one started. Now there's only 3 screws on this. Okay, now I'm going to go ahead and work my gear and just make sure that I feel the motor engaging. And it is, so that's awesome having access to that gear. I'm going to put this up so it's out of the way. I don't think we have any other bearings that need grease on them. Put that down there for the next operation. I'll need grease. Toss these away. Got too many of these, so we'll toss those away. We'll need the clip and the PTFE tube. We'll set those over here for now, out of the way. Like my thing's about to fall off. Okay. Up next, we'll need our motor and we'll need to press the gear on. I don't have the gear yet. We should be good to press that gear in after the fact, right, Rob? So I think we're going to mount this one in the same direction. So that's for that one. Press the Z-motor gear onto the NEMA 17 shaft. The gear T should face the body of the motor. Note that this is a slight interference fit and it should not slide. So it's an interference fit. If it slides right on there pretty easy, reslice it, drop it by 1%, reprint it. Yeah, you can press it on after. That's what I was thinking. And you don't make a mention of which way the motor connector would go. I'm assuming it's going to go in the same direction, facing towards the front of the printer. And these are M3 by 10s. I'm going to assume, does it not say? Does not say. But they're going to be M3s, and M3 by 10 is the shortest. They're definitely not M3 by 20, so. Grab 4 of these. Now, folks, also remember, you want to Loctite your grub screws, if you have grub screws, but don't put Loctite and then run your screw through a printed part. I'm pretty sure it interacts with PETG. I know it interacts with ABS and PLA. PC or nylon, you should be fine, but just be careful and cognizant. And these, we're not dealing with a lot of shaking and forces here, so these motors should be fine. So honestly, Rob, I think these could do with, well, this one driving the rear should probably be a big one, but the extruder could probably be a smaller one. And I know what they did. They bought all the same size so they didn't have to mix and match. But now it wants me to assemble the roller. Once again, here's where I'm out of 3D printed parts. So we're kind of at a standstill. I should have started printing on multiple printers, but I wanted to print it all off on one printer. That way, if I have fitment issues, I know it's with a printer. And when I go to do this part here, where it suggests lightly wrapping with electrical tape or Plastidip, is this like really pressed down in the grooves or lapped over the grooves? that are in this 3D printed part. That looks like it's just stretched tightly over the grooves. Yeah, and then the depth or spacing on this gear shaft is going to be dependent on the alignment with the other gear. So we'll be prepared there. Can't do that, can't do that. That's what it would look like with a Raspberry Pi going one direction. Like I said, I knew I was not going to have enough printed parts done. Shouldn't have got rid of my thing, because what we can do right now is we do have 3 rails that need to be lubed. And I didn't even think about it until just now. So we can go ahead and lube those rails. We are continuing to print. Like I said, I'm printing all the parts out on the the Creality. Yes, it can be printed in PLA. The only thing that you would need either in just over the grooves to provide a little more tackiness. Okay, cool. In the smooth PLA, gotcha. The only thing that shouldn't be printed in PLA would be this part right here. This is the bed, right? Facing up, it would be a heated bed. You face it down, it would be a non-heated bed. And this is to provide support to the bottom of the belt right at the print area, and provides heat and warmth. So this is printed in ABS. It's the only thing. And in fact, I do need to hit this with a little bit of heat. You see the white marks on it? Those are stress marks from when I popped it off the build plate. And on an ABS print, with a little bit of heat from a heat gun, let me just warm up in a second. You can see that as I apply heat, the stress in that part goes away like magic. So you see that big white mark right there? You can do this on your ABS and ASA printed parts. I know I normally just leave them on my builds, but you can do like that and it cleans them right up. I can put this over here so I can burn myself on the hot edge later. So this is the only part you want to print in at least PETG, but preferably ABS, ASA if you have the option. We're going to go ahead and bring this back up, and I'll go grab my grease again, and we'll take these rails out and we'll grease up the carriages so that that's done. And like I said, Pez always comes around, and that's normally my reminder that I've got to lube something. I think you missed the M3x10 and the connector hence higher up the page, just over the grooves. to provide a little more finesse. Okay. Learning new things every day. You don't print much ABS. Yeah, I print a lot of ABS and ASA, and normally I'll say I don't care and I don't mess with it like that, just because the majority of the printed parts I do, that part's not the part that shows. So I just really do it for a cosmetic thing. Oh. Hey, Down Under Maker, how's it going? Good morning to you, sir, or ma'am, whatever the case may be. Um, we're kind of jumping around on this build a little bit. Um, I decided to go ahead and start the build. We opened up the kit and kind of looked through the kit. And I keep forgetting that there's like next to nothing part-wise in this kit. So it's not the same as unboxing a rat rig or a VZ bot or something like that. And I'm in the process of printing the parts still. And I'm trying to print all the parts on the same machine, which is the Creality behind me, because I need to get some break-in on that. I've got some new parts to try out on it, and I want to make sure that it's printing good before I start putting new parts on it. You should always do that. Always, make sure that the printer is printing and printing well before you take it apart and start trying to do mods and stuff. If you start doing mods on a printer before or as you're building it, you may chase, I'll say, ghosts that are of your own making. Now, what I do, I know a lot of people will come in through the back and just squirt through the whole thing because your dust covers are going to keep it from squirting out the side. It'll come up on either side of the rail. But what I normally do with the rail or the carriage over, slide my rails off. And I'm just going to look and see the quality of these before I do anything. Make sure, because sometimes if you get the really cheap ones, you may already be missing balls. And now we're going to take some of our EP2 grease. We're just going to run a bead down each side. Let me bring you all in here. Closer. Okay. So this is why I like the syringes, is I can take and run a bead right down each side of the bearings. And I'm just putting a healthy bead on there. And then I'm going to use my finger and press it into the balls and the raceway on the side. And I'm pushing it down in there, and then I'm going to run my finger along it, which should rotate the balls through the one side. Being careful that you don't shoot one out. You do. Well, that's why I'm on a piece of paper towel. It'll be easy enough to get it back in there. All you're trying to do is get grease down into the channels, because otherwise you're pretty much metal on metal, and that's not good. You're having a hard time getting your balls to move through the gap. I can see one of them came out, so grab a pair of tweezers. And by this point, we got a little bit of grease there, and we've got, like I said, our paper towel here, which makes it easier and makes it so these tiny, tiny balls don't go shooting all over the place. These are a little bit harder to do because of the size of the ball bearings. because of that, you want to take like 2 or 3 at a time and route them through there. You're just trying to get them to go through the raceway some and distribute some of that grease. Yeah, you try to keep the bulb simple and accessible. That's true. I mean, you've got very few different screw types on here. If you're dealing with a bigger printer, you're going to have a bunch of different sizes to go through motor stacks and everything. I mean, here we've got M2 by 6, M2 by 8, M2.5 by 8, M2.5 by 12, M3 by 10, and M3 by 20. And really, the smaller ones that you have here are just simply because of the size of the printer. If you made it bigger, you could have gotten rid of a lot of the 2.5 and the 2 millimeters. But when you go with these smaller rails, you're going to be using, I think these will use the 2 millimeter for the rail connections. Actually, I don't think you're actually connecting, like there's no, normally we connect the rails to a, like a piece of extrusion. You only do that. It's the rail carriages, yeah. Okay, so we're like that. We've wiped off this rail to get rid of any of the travel oil. And when you go to put this on, I kind of angle the edge on just like that. And then you want to put your finger down in here and basically squish the spring. There's the little spring retainer clips on here, right? I'm going to put my finger down in there to press that retainer clip against the balls so that they don't go jumping out. And I'll just start sliding this on, moving my finger back as I go. When I get close to the end, I'm going to look. Look at my finger. Once again, I'm doing this on a paper towel so it hits and it stops. It doesn't go rolling around on the hard surface. And there's grease in there, so if anything, if a ball popped out, it's either going to be still in that groove or on my fingertip here. And now I can slide that on all the way. We'll test that movement out. Moving pretty nicely there. We'll wipe off any of the excess grease that popped off. And now, the critical piece. Put your stopper back in on both sides. That way you have less of a chance of knocking that carriage off. And at least on a larger rail, if you knock the carriage off and the balls get freed, they're bigger and you can see them. If you lose these balls, good luck, especially if you're like me and have carpet, you're not going to find it. Once again, we'll take the stoppers off. We'll flip that over onto the carriage top. We'll pull the rail. Now I'm going to try and just wipe the rail down or dab it down. Once again, I'm trying to get the bulk of any shipping oil or lube off of it. Then we'll set that to the side. I like to get that off because it's normally just crappy and it's either like water, it just gets on everything, or it's like, I'll say like mud or tarnish. It's just because they've crapped it on there so much. Are they not grease ports on the ends of the rail? I would doubt very seriously if these would be working grease ports. So on this one, no. Well, this one has what looks like a port on the end of it. I can pretty much tell you, I doubt very seriously if I would get any grease to go through that port and through the raceways. I might be surprised. Yeah, it's squirting out the port, but it's not coming through the raceways. A lot of times on these small ones, those ports are about useless. The larger ones, definitely though, and especially if they've got an actual like angled grease zerk fitting, those will be good. Like my Milo and my rat rigs, right? Like my rat rig sitting over here, it uses HG 15 rails, so 15 millimeter rails, and it's got genuine like grease zerks on it. So you can actually take a grease gun, connect it up, and grease the rails in place. And once again, my Milo mill and my Millennium Machines Milo and my rat rig mill both have the larger rails on them that are capable of being greased in place, so you don't have to take them off and take it all apart to grease things, which is nice. When you're doing this for the first time, just try and skirt like 2 or 3 balls through at a time. If you try and do a big long run, that's normally where you wind up squirting a ball or 2 out. I did just there. Come on now. Hey, nice. But that's why you're trying to get grease in there, is to make these things roll and slide a little bit easier rather than just trying to pop out. And I normally run these around once or twice. Also on the cheaper rails, I mean, I haven't done it in a while. Normally it's probably not a bad idea if you're really like if you're building a CNC from the ground up, right? You're buying good parts, you're putting a lot of money into building a precision mill or a CNC or a lathe. Take your carriages completely apart and literally run them, like not the bearings, but run the, keep the bearings to the side, run the carriages and the carriage itself through an ultrasonic cleaner, or potentially soak them in IPA overnight, and then clean them out, blow them out to make sure that there's no, you want to rinse all the IPA off with some water, preferably distilled, and then blow them out with a compressor, which you would probably have if you're building a CNC from scratch. Blow them out nicely, make sure that all the water's out. Clean your balls with IPA once again. Don't ultrasonic cleaner them. You will put little microscopic grooves in them. But clean your ball bearings and then go through and put them back together and grease them just like I'm doing here. And once again, your larger, I'll say, rails and bearings for your big mills and stuff, you'll have the grease port that you can actually install grease with them once they're installed. So basically what you're doing is preloading them with grease, and then as you run the machine and it starts getting up to heating temperatures and stuff like that, then you can go through and grease it back up again and maintain it with grease. I know this is something that a lot of people don't do. And especially if you open it up and it's just full of a shipping oil, like it came from China in a bath, right? A lot of people will just take those off and just put them right on and run them. Your mileage may vary, but that is a low viscosity oil. It will dissipate and disappear very quickly, and you'll be left running them dry real fast. And I know what, so I ran a Sherpa Mini on my Ender 3 for a long number of hours and failed to do proper maintenance and get in there and re-oil it and stuff. And yeah, I cooked the needle bearings and had to buy a whole new set of needle bearings for the idler. It destroyed the shaft on the idler. So, but that was running several hundreds of hours, and it was in a enclosed, because I was running ABS on it in an enclosure. And yeah, I blew that extruder apart. I had to go through and do a rebuild. And sorry, let me look up and catch up on chat. Okay. But yeah, it behooves you to look at your parts. This is not that's not a bash on any kit manufacturer. It's just the fact that a lot of these parts are still coming from overseas, whether they're coming from China or Germany, if they're high winds or whatever. And they have to figure out how to protect them for the boat trip, right? That was pretty good. Rail started. Once again, I'm going to put my finger in there and press the spring clips to the side. Slide my finger down with it. Look as I get close to the edge, look at my finger, look in the grooves, make sure I didn't lose a bearing. And boom, there we go. Now we can work it through. We'll get some of that grease down through the channel in the rail. We can clean everything up again. I'm fine with grease down in this groove because that's where the grease needs to live, is down in the groove there. But all the grease that comes up on the side, that's useless. It's not doing anything. So that's why I'm trying to wipe that off, but I'm not trying to get down in the grooves because that's where I want the grease. That's where the balls are running. Then once again, put your stoppers on. The other thing I will say is periodically, as part of preventative maintenance, I will go through with some, it's downstairs right now because I was wiping down the 0G Mercury 1. Get some 3-in-1 oil with Teflon or PTFE, right? And every so often, take a paper towel, get oil on that paper down, and wipe down your linear rails. Yeah, the last mile carrier. Well, and you also don't know how long it sat at a port. So it could be sitting in a port city in saltwater air. So yeah, I mean it could be anything. Um, the what am I trying to say? Um, but taking some 3-in-1 oil and putting it on a rat or on a towel like this or a shop towel and just wiping down the exposed area of the rail will ensure that there's a light coat of oil on it, and that will prevent any rust from starting, because I have had rails rust even though they're stainless steel or were marketed as stainless steel, I will say. Um, so yeah, just be cognizant. It's all printer maintenance. Now, mind you, if you get a brand new printer that was new in box and it's got rust all over the rails, I'd be taking it back. And I would rethink future purchases from that vendor. I was sitting on one of the Discord forums, I can't remember which one, and somebody was talking about having to tear their printer back apart and um, clear the rust off their rails again because they had it partially reassembled and left it sitting there waiting on parts. And it's growing season now. It's springtime, so people are starting to run, all their seed stuff in house. Well, you normally start running those with a heated container, right? So you've got a heater and moisture, and you're creating humidity for those plants to start growing. And they were waiting on some parts and they weren't paying attention. And by the time the parts got there, the rails had started rusting again. So they had to go back and take everything apart and clean the rails again. I mean, it's surface rust, so as long as you don't let it get to the pitting stage, you're fine. But just stuff that needs to be done depending on your environment. Do you have a lot of problems like that, Free Heathen, if you're still here with stuff? Because you're Pacific Northwest, right? I mean, Canada Southwest, but what we still consider the Pacific Northwest region. I know if you're around the coast, and especially things like I know Oregon and Washington State get a lot of rain. I would assume that part of Canada gets it as well. Come on now. Take your time, go slow. When you start trying to force things, that you wind up doing something bad. And like I said, you don't want to lose these balls everywhere. You can buy replacements, but the best way is not to have to replace them to begin with. I'm going to do 2 rounds, maybe a third if it feels like it really needs it. And then get the carriage back on the rail. So you don't have any loose balls, and clean up any excess grease that spooges out. Everything on there, and we'll put these back on. Your tools, put those up, grease up. And we've got 3 rails ready to go for the next round. I think these are the same size as the V0 rails, right, Rob? Use mineral oils. Okay. Try and reuse those gloves at least a couple of times if I can, but you think so? Okay. I'm not sure how much more I can go now because everything else requires some type of printed part that I have not printed yet. And we'll have everything printed by Thursday though, which will be the next stream. This really is it's not that hard of a printer to put together. If anything, it's like the V0, which is to say it's just small, and small things can be fiddly. All right, this is something that we can possibly do for prep work, which is look at our NEMA 11 motors. We can put our GT2 16-tooth pulleys on it. Okay. We can use our calipers like Rob was doing. You can use a ruler, whichever works best for you. Whichever you feel gives you the most accurate measurement. I'm going to start and use my calipers similar to what he did. I'm going to set it to 7.5 after I unlock it. Seven and a half. And we're going to need our pulleys. These do have their set screws in them. There are 2 on these, so you'll need to take them out, put some Loctite on them. Don't need a huge amount, just a little bit. And we're going to get this on here. They're flat. There is a flat. Get that started. Flip this way. Put this here. Ever so slightly need to go further. Here we go. Tighten on the flat first, and then tighten to the round. All right, down under maker. Sounds good. So there's one of our motors. And are we doing both to the same distance? Looks like it. So go ahead and get this next one ready to go. We're between the desert and the ocean, so the air is always humid in the afternoon and salty. Oh yeah. Oh yeah. Rails got to be kept greased. That is true. Anything, uh, whether it's a firearm, a knife, rails, anything metal, you got to square those away and take care of them. All right. Whoops. There's my other motor. You can do this the smart way and put the flat to the top. Hey, Jedi Spidey, how's it going, friend? Are you ready for, I was going to say next weekend. It's not next weekend. It's 2 weeks from now. You going to be able to come down for that? All right, so we've got both of those done. Make sure you shut that off to save on your battery. Put this back over here. You'll be in Carolina Beach that weekend? Doesn't sound like a bad way to spend the weekend. All right, so we got our rails greased. We got our 2 motors over there done up. Can't really put this stuff together because I don't have all the printed parts yet. This is a grand idea, by the way. We got our 2 smooth pulleys underneath there. You run the belt through. You use a driver to grab the belt, pull it over to the side to make the loop, and then you put your motor in so it's around the belt. That is a fabulous idea. Pretty neat way of tensioning the belts. That'll be some wiring. Go in the bed. We could probably go ahead and prep our build plate because we're going to have to do that anyhow. And then we can do a little bit more wiring. So we slide these over here, so they're kind of up and out of the way. We'll put these over here so I can knock them off like 18 bazillion times. Build plate. What do I do with the build plate? Build plate is right here. Because we've got a standard build plate, we don't have one of the cool PEI ones that Rob was showing off. We need to go ahead and put our bed heater on. Come on. There we go. Not throw this around, Luke. Get the sticky stuff off. This is the side that has the depressed holes, so this would be the top side where your screws are going down. This would normally be where you put your magnet is on this side, which means this is the side that we're going to put our heating pad on. So I'm going to set it back down here, and I'm going to clean this off. I'm setting it down here so I don't scratch it up or scratch that up. But we need to wipe it down and get any milling, machining crud off of it. And you'll be surprised. I've had some of these that have come out really clean, and I've had others that have come out that look clean like that, but are pretty dirty and nasty. So we're just going to take a little bit of IPA, put it right on the bed, take our rag, oh, that's not going to go good like that. So there is a bit of a rough edge to this. So if I go against that, so you can see where they fly cut it, where it has the horizontal lines there. So if I go like this, it's going to leave lint on here. So we want to nicely wipe it down. And that's not that bad. I've definitely had beds a lot worse than that. Okay. Let that dry and flash off. Got a honey badger heater here. We've got cutouts down on the bottom side that'll go around the mounting screws, and a cutout in the middle for the other mounting screws. So this should be pretty close to an edge-to-edge heater. Trying to visualize it. Okay. Now on a bigger silicone pad, I would just take off one little piece and get an edge set. Make sure that I'm nice and clean on the edge, and then start pulling. But these are so small, not sure if I'll be able to do like that, like I normally do. Back. That was weird. This had like 2 pieces of adhesive joining it. I will say that this is the first time I've had this. On a honey badger or otherwise bed. That was weird. I'm trying to pull this back so I can leave. Normally I do about 1 inch. I'm going to go a little bit further. Fold this down. And that's going to allow me to kind of line this up where I want it. Side to side, edge to edge. Front to back. Press that front edge down. We can reach under here and grab that paper and pull it out and work our way from front or back. Be careful right here. You've got a thermistor in this pocket here. So you want to make sure and go all the way around it very evenly. But you want to watch out for that area. Now, normally what I will do is set something solid underneath this with a gap around that, and then put a couple of spools of filament on top. And that'll just, and let it sit there overnight. And that'll give it a good pressure seal on this adhesive. I don't have a roller like Steve Builds uses, but this is good enough. There's our heated bed prep. I'm pretty sure we don't need this long of a cable. I'm pretty sure we'll be cutting this shorter. Just saying. What else? The other thing I was thinking is we did have motor wires here. This is going to be for the 2 motors that we've already installed. So we should be able to take these and install them. 6-pin side goes to the motor, 4-pin side goes to the board. So I think X goes side to side, Y is the vertical up rail, and Z is the belt. So this is driving the belt. So we'll plug this in to the motor. We see to run this underneath the other motor. Plug this in. So what I did was run it underneath the motor, plugged it in. Now I can bring this over and we have X, Y, Z. And this is a paralleled Z, so X, Y, either one of these will work, and then E for the extruder. That would be the extruder motor. We're going to kind of bring this around and plug it into the first Z motor. Then we'll just kind of push that down and out of the way. Once again, X is going this way. Y will be the vertical rail. This is going to be the extruder motor. So the one all the way at the end. Plug that one in. And this is going to come around and plug in here. Once again, we'll tuck our cable down underneath, like so. And that's starting our wiring. We'll work on this as we start building things in. And I think I might actually go, we'll get the belt ready to go. But I think what I might want to do is put the front on and get the X rail going so that we can kind of get in here a little bit easier, big hands, and get things plugged in. And then we'll add the belt and do the back part of the printer. So we're going to kind of work out of order, but I think it might help us out a little bit by doing that. And then between now and the next stream, I'm going to be contemplating to myself whether we're just going to run it straight Marlin or if we're going to put a Raspberry Pi in here. I need to see, I think I've got a zero. I'm not sure if I have a 02W that I could fit in here, connect onto, if we do the 02W, I think we can connect into the TFT port to pull the power, because I believe the screen is going to come off of the, oh no, the screen uses the TFT. Well, dang it. I'll have to look and see where if I can pull UART any other way. I think if they're using that one, we might be stuck. We'd have to do the cable. Well, that would stink. But anyhow, here we go. There's the baby belt so far. Once again, this is Greengate, Your Royal Highness recycled PET G. We got our extruder motor, our Z motor, which will be the Infinite Z for the belt. We're going to have our faceplate come here. This will be the drop-off plate. And by drop-off plate, I mean the ramp that comes off the end. Part fan, hot end fan. Yeah, we're gonna have a lot of wiring to do. Yep. I think that's where we're at for now. We're kind of stuck. I can't go any further without additional parts printed and, well, they're printing. We're almost done with the, let me go full display here. We are almost done, whoops, there we go, with our, this is the ramp. This will go at this end, and this is the faceplate, so that'll go at the front end here. So we're almost done with these parts. We're about 77% done. We got a little over an hour. So I'll be able to pull these off tonight and get the next plate going. The next plate's going to be I was going to say it was going to be a plate of a bunch of other parts, but side, front, or screen and end. Yeah, this next part's going to be the XY motor bracket and a couple of other parts. This will take a while to print just because that motor bracket is oriented in an upward direction so that it has the strength that it needs in the specific way. And then we'll have 2 more trays to print that are, at least one of them is going to be a lot of small parts. But they're going to be printed in the Magic Magenta. So it's going to be this color here. So Magic Magenta. Oops, wrong one. So it's going to be this color, which is a real pretty color. This is actually one that Mrs. Dragon picked out. So that color right there. And I'm going to have to go down and buy another roll because, well, it was Miss Dragon's. So I've got to go and replace it. I can get it out at Ecovate as long as they've got the color there. But that's kind of where we're at for now, folks. We're at a stopping point until I get the parts printed. When we come back Thursday, we should be able to make a lot of progress. I think what I want to start off with on Thursday, we'll get the front piece in. We'll leave the back and the belt for last. We'll get the front piece put in, and we'll build the XY. And the only reason I'm saying that is to be able to get big hands in here to do the wiring. I want to be able to do that without having the belt pre-positioned on here and everything. So we'll leave this backside open so I can get in here and get to everything a little bit easier. Okay. But we'll be able to get that done. Like I said, this is going to get trimmed down. This is way too long for the purpose that we need it. So we'll cut that down. We'll build the XY, and we still need to make our own belt. So that'll be cool. I'm probably going to do a belt off stream, and I may still do a belt on stream, but I'm going to want to do one off stream just to make sure that I'm like, I don't know, doing it right and I'm not screwing it up. Get at least one belt under my belt, so to speak. But yeah, I think this is where we're going to stop for today. I was hoping to be working on the Trident. We hit a roadblock with the Trident where we need to wait for some parts to come in for a different motor. Or if I decide to go with a different extruder package, I need an EBB 36, which should be here tomorrow either. So chances are we're going to do the baby belt again on Thursday. We'll work on the Trident again on Saturday, and it should be up and running. I really want to just slap a different motor on there, and hopefully it fits and it works, and we can just keep going. If I have to switch extruders out, then I'm having to reflash a different tool head board. The EBB 36 should be a drop-in replacement as far as all the wiring goes, but I still have to flash the board and maybe redo some pen mappings. It's not too bad, but it will be something. The easiest thing would be just to get a different motor that correctly fits, because once again, the shaft and pinion gear needs to be 5 millimeters from the I'll say the black face to the face of the pinion gear, right? Needs to be 5 millimeters. Mine on the Bondtech motor I have is 5.2. So it's actually binding because it's sticking out and touching the back side of the 2 large gears that are pulling the filament. So as soon as there's any amount of tension trying to pull that filament through, it binds the motor unless I overcurrent it. And it was getting really hot because it was trying to do that. So I'll go get the right motor. I'll stop trying to overheat things. And worst case scenario, by tomorrow I should have an EBB 36. So if I need to swap out, we can swap out, because I do have a CNC FISEC Sherpa Mini. I just need to throw a motor on it and get the EBB36, print a new mount, which I can also do as a preparatory step and be ready to go. All right, folks. You see the printer printing? Yes, that one's printing right now. And this is why, like, I've got plenty of printers. I could have printed all these parts all at the same time. I didn't want to. I wanted to print it all off of this printer. So if there's any fitment issues, I know it's something to do with this printer and not the fact that I printed it on multiple printers, right? Yeah, it kind of looks like a baby. This one kind of looks like a baby compared to the Vorons and some of the others. But I mean, it's a standard inner bed size. I did print some feet for it. So Devil Design has some feet for it, and basically we'll take these feet, okay? Here's where the base of the printer will sit. We'll take the existing feet off. We'll take the rubber foot and move it down here where it will align here and screw in. The base of the printer basically goes here. There's a screw here, and actually there's two screws here that are for one of the side panels, and then this would be the front. So this would be the left front, this would be the right front, and then we got the back one. So it gives it a little bit wider base, so it shouldn't shake itself apart as much or shake the table as much. But that's the same color blue that we're printing the baby belt in. So we'll get that and give it a little bit wider stance. And then I've got a couple of other upgrades coming for the Creality that I'm not sure if I can actually talk about just yet, but they will be going on the Creality. That's another reason why I wanted to put more time with different materials on here. I do have a, what do I do with the nozzle? So I do have a couple of spare nozzles for this, but I also have an in-coat nozzle and a silicon carbide nozzle for these printers from Vetus that they had sent me. So I'm going to slap one of these in as well, and that'll give me some abrasion resistance, because I don't know if those, I think those are just standard nozzles in them. I don't think they're hardened. So, not that it's going to be tall. It'll be a little bit taller, but it's going to just give it a wider stance. Like right now, it's kind of narrow compared to its height. And we kind of want to give it a little bit wider stance at the base so that it doesn't do one of these numbers like a skyscraper does, right? Trust me. I was sitting here in a meeting. Luckily, I was muted because this, aka my trad rack, I had sitting up on the top. I had it sitting up here. And I had it sitting up here at the back. It hobbled its way all the way to the front and fell off on the floor and scared the bejesus out of me. It's a good thing that this needed to be rebuilt anyhow. But yeah, it scared the bejesus out of me. Not over there. Okay, good. So yeah, I mean, that's just vibration. It does things like that, right? But let's see who's up and running that we can raid out to. I know Jano normally runs on at night. Tuesdays, Thursdays. Master Canucks up. Oxen, Cyber Jewels. Fuzzy. Holotech's up, building a printer. Polymaker's up. No big Jano yet. No Jano yet. Huh. Actually, you know what? I wonder if we can go ahead and put our bed on here. Basically how the bed's going to sit on there, and then this will sit. I believe it'll go in there like that or like that. I think it goes in there just like that. So that's how that's going to sit there. So you can see our bed heater wire and our thermistor are right here. So we're not going to need the, oh, sorry. Our bed's going to sit on the plate like this. And then, we've got 3 feet of wire to go 6 or 7 inches. I mean, we'll want some wire that we can push up underneath. That way we can take this in and out and leave it connected. But this is how the bed's going to slot in there. Is like that. So we're definitely going to be cutting this cable down to take up some of that length. I'll just leave that sitting in there for now. Um, okay, I was trying to figure out RAID. So we can go. How's Polymaker doing? Because they normally raid into me. Is Polymaker almost done, do you know? Because I don't want to like raid in if they're getting ready to be done and raid out. Looks like he's still going. So, okay, I'm going to go ahead and raid over to Polymaker. Please feel free to jump as soon as we raid in there. Jump on in. Remember, it's I am awesome in chat. And that'll get you entered into the giveaway. Make sure to do that when you jump over there. We're going to go ahead and head over to the Polymaker here. Thank you all for being here once again. We'll continue to work on the baby belt on Thursday, and we'll have a plan for finishing the baby belt and the trident by Saturday. So thanks, everybody. Have a great day, and I will see you guys on Thursday. Bye now. For those of you that are watching this on YouTube, thank you. If you like the content that you see, please feel free to like and subscribe down below. Be sure to check that bell so you get notified of future videos. And YouTube's going to be suggesting another video right over here. Thanks all. Have a great day.